Yeah, hopefully my screen is visible.
Yeah, it is.
Yes, so I just show an image here. NGC 5189 Hubble. And on ESA Hubble, this is the official website where they upload their images. And we are going to try to recreate this image. And this is another SHO image of filter set, popularly known as Hubble's palette, which was mainly explained last session. So we are going to try to recreate that. And if you scroll down, here are the few filters which are used over here. But mainly we are going to use these three filters, that is H alpha, S2, sulfur 2, and oxygen 3. So our image won't exactly look like this, but we will get a really close replication of this. The colors are going to be the same, the background will be the same, the structures are going to be similar. What it will lack is like some detailed structures, some whisks over here. So if you can see, this nebula is a planetary nebula or a supernova remnant. So a star has just exploded and has caused this shock wave to be formed. You can see there are like two shock waves over here. One is like this and the other is like this, complementing each other perpendicularly. So this is a really a beautiful object in the night sky. It's pretty small actually, like in its angle, uh, and we are going to try to process it. So here is the data set which I have installed from HLA or the Hubble Legacy Archive. It's there online, so you can simply search HLA and get the data set. It was actually explained uh, last processing session. If you have attended it, uh, you can easily fetch the data from there. And yeah, this website. So you can do it easily. I have already downloaded the data sets over here. The three filter sets, F502, 657, and 673. These are the nanometers of the wavelength, and they represent SHO, uh, like in the opposite direction. And these are the two softwares that we are going to use, Cyril and GIMP. Cyril is for the pre-processing purposes, that is mainly stretching the data from linear to non-linear format. And GIMP is for like the final touch-ups, which is also important because we want to make the image a bit more appealing and beautiful. So over to Cyril. First, we'll click on open. Here I have already set the home directory to the folder, and we'll start by stretching all these images. First, we'll open 673, that is S2 or sulfur 2. Open. You can see the image is in a compressed state or a linear state. The histogram is all aligned towards the black pixels. We want to stretch the histogram. So if you can see in histogram transformation, the histogram is concentrated. The line is over here to the left. If I take the cursor a bit more on this side, then it got stretched, but the image is so faint and compressed to the left that the effects aren't visible. So I can apply this, I can stretch it again, apply this. A bit more details are getting seen over here. You can see like this, like this. And now something's about to get popped. Yeah, like this. And you can see the histogram is getting stretched. So what this auto histogram does is this basically it stretches the histogram on its own. If I just click on this, then it will get stretched on its own. So this entire process is automated using an algorithm. So what I would suggest is whenever images are in such a configuration like cropped and they have got black borders on the background, if we use auto histogram from the start, so I'll just show it. So I'll have to like cancel all these processes once. And so if I use histogram transformation and auto histogram here, this does look the same, but you can see the highlights are a bit clipped over here. That means the dynamic range. It was explained in module 4. I don't know if you guys have read it or not, but I'll just try to recap dynamic range again. So that represents the difference between the black point and the white point. When that difference is less, that means the highlights are a bit more difficult to distinguish. That is, the highlights can be clipped. So that dynamic range isn't as appealing. What we want to have is a broad variety of colors, black, gray, and white. We want to have a bit more depth in between that. So more shades of gray basically. So that represents a good dynamic range. For that, we won't use histogram transformation. What we are going to use is arc sine stretch. So it's similar to histogram transformation. There are other kinds of stretches also, like logarithmic, square root, squared, and there's arc sine. So sinh matlab sine hyperbolic, and it's the arc function of that. That is the inverse of it. So here is stretch factor, and here's the black point. It's a bit more simplistic to understand compared to histogram in terms of use. So we'll stretch it a bit more, and the data is really compressed. So one stretch won't do it a lot. So we'll have to stretch it again. And yeah, certain details are getting seen now. Okay, again. Now it's a bit more apparent. Okay. We don't want to stretch it a bit more aggressively because now we are just doing a basic stretch. And after stretching all the three filters, we are going to combine them using RGB combination. So RGB compositing, yeah. So after combining these three images, we will stretch it a bit more in GIMP also. So I've stretched this like this, and we'll just increase the black. Okay, not so much, a bit less. I think I'll have to stretch it a bit more. And now I can use the black point. So black point just increases the shadows region. So it makes it a bit more dark, but here I don't think so there's any need for it. So if you remember, after histogram transformation, the highlights were all clipped. So the white region, that is a central part of the planetary nebulae, was getting clipped over here. But by using arc sine stretch, what we have done is preserve the dynamic range. So nothing is as such extreme in this case. So everything is neutral. So all the details aren't getting like overexposed or like totally white and washed away. You can see all the details very clearly, and the image is like a bit more detailed and crisp over here. All the emissions and shock waves are visible over here. So this is the kind of look we are targeting. So this is it mainly with this. So we'll get and save the image over here. Just make another folder over here for stretched images using ArcStretch. By stretching, I mean to stretch the histogram. So we will save this image as 502. Okay. Was this 502? This was 673. Yeah. Okay. And the format which we want is TIFF 16-bit. Now we'll open the second filter, and I'll go through this process a bit more fast because it's nearly repetitive. So image processing, arc size transformation, stretch factor, apply, arc size, stretch it, apply. It's loading. So you can't rush through these processes a bit much because of computational restrictions also. So if you have a fast processor, then you can go through it a bit more fast. So I think This should be fine. We don't again want to clip the whites because arc sine stretch also in a bit more aggression can cause the white point to be clipped, which we don't want. So like if I take this a bit over here, then we are going to get the clipped result, but not as much as histogram. So we are going to keep it in moderation. By I think 371 is a good scaling. And black point, I don't think we need to fiddle it around with it. So this is a good stretch. We'll save it. This was 657. I have to click if and why did I cancel it? My bad. Sorry. It's 16-bit save. Similarly, we'll open the last one, 502, and it's in the linear state. So we'll stretch it, image processing, arc size transformation, stretch factor, increase it to about 900, arc size, again increase it, arc size, okay. I think this is good enough. We'll save it. And save. 16-bit and save. Now we'll go to image processing and RGB compositing. So we want S, H, and O, that is sulfur, hydrogen, and oxygen. Sulfur is on, so if you remember the wave band, I'll just open it on Google just for a quick recap. SHO wavelength graph, not this exactly. Sulfur, hydrogen, oxygen, nano, filters, graph. Yeah. So this one is a nice representation of it. So sulfur is a bit more to the red side. Hydrogen alpha also comes under red, but we'll give it green color because it's relatively towards the left. And oxygen 3 is on the blue side. So according to this graph, we are going to give this red for sulfur. So under stretched, we are going, okay, this didn't get saved. 57, I think it got saved over here. Take up. So sulfur is 673 nanometers, which will go in red. Okay, yes. Green will be 657 nanometers, that is hydrogen alpha. And blue will be oxygen 3, that is 502 nanometers. So once this is done, we can click over here and you can see the image looks a bit ugly. It's not close to what Hubble recreated. The reason for it can be because we didn't use as many filters, but we are going to try to recreate this. How we can do this? So what are the first problems in this image? We'll answer those. So what can you see in this image that isn't as appealing? So if anyone in the chat wants to answer, maybe they can. So you guys want to try to answer this, so we'll just give you a moment. So in the chat, you can type or unmute and answer. So what was there in the image which wasn't as like appealing and it was looking ugly? I'll just display the image once again over here and you can have a look at the image. So okay, so I'll go through it myself. So first things first, the blues look all right. Green is a bit ugly color to have in an astro image. You can see the Hubble's image of this was had orange over here, representing hydrogen or sulfur. We want to have that. So we want to eliminate the green. Second thing which looks ugly is the background. So the background over here is neutral and black in the Hubble's image. In our case, the background is like totally orangish over here. This background. I just zoom in so you can see it. So the background over here has got an orange tint over here. We don't want that. We want the background to be neutral and black, right? So for that, we are going to process this in two steps. First is we are going to eliminate the green. How can we do that? So we will use green noise removal. Just a second. Remove green noise. Yeah. So this is an CNR transformation that removes the green noise, and we are going to set it to default values. And this is a basic algorithm which removes the green noise from the image. This isn't exactly noise, but this is a misrepresentation of colors of Hubble palette. So we'll just apply this and click on preserve lightness. If we don't do this, then the brightness values of the image can get manipulated. So we have to preserve brightness to keep the light pixels the same. We just want to transform the colors. So we'll just click on apply, and in the console bar, you can see the script that is getting used actually. So Cyril has got this nice console bar where if you know a bit of coding and scripting, you can in fact make all these processes on your own. So over here, these are automatic, like pre-made algorithms. So you can use them and you can see all these scripts getting used. So the execution time was 6.66 seconds. And you can see the image looks a way more closer to what Hubble had recreated. Not as quite, but the colors look fine. What's left is the background. It looks a bit orangish. So we'll go ahead and correct it. So for correcting the background, I guess we'll have to crop it, but let's give it a try without cropping also. So under image processing, and we have to go down to background extraction. Here we have to select a neutral area of background without any stars. So just go ahead and select this small section over here. Okay, why didn't just get selected? Never mind. Just a second. Okay, so my bad. It wasn't actually background extraction. This is used to remove any background gradient. So like uneven distribution of background. So we won't use this. We'll go under color calibration and select color calibration. Yeah, so I'll just select this small patch over here. So you can see there aren't any stars over here in this patch. So this is a pure selection of the background, and you click on use current selection. These are the pixel values of this background area. And next we'll click on background neutralization. Yes, so this is a nice background, but it in fact reduced the orange a bit more. So for that, we can tweak these parameters over here and have it have a bit more freedom. But in my opinion, the background looks a bit normal and neutral. We can control the oranges in the periphery of the nebula in GIMP as well. So I think we'll go ahead with this result and apply. Okay, this is good enough. So this is before. The background looks orange, and this is after. The background is a bit more neutral. Okay, so this is mainly with GIMP. I'll just go ahead and explain different color calibrations. So this is the first one, that is manual color calibration, where we select a small region of the background. The software takes that as an input and takes the color values of that image. So it tries to equalize R, G, and B such that we'll get a neutral grayish black background, like in space. That is an accurate representation. But something that's more accurate is photometric color calibration. This we won't cover in this session, but it's a useful feature to have. So you can enter the target over here. You can enter its coordinates manually as well. select the focal length and pixel size of the camera, the telescope and camera which is getting used. So Hubble has, I don't remember the values of Hubble presently, but you can set it over here and you can click on OK. So what this does is it corrects all these stars based on its photometry. So what it will do is it will align all these stars based on a catalog, and it will try to accurately represent the colors of these stars. So by correcting the colors of these stars, the nebula's colors will be automatically corrected. So this is a much more scientifically accurate method, but we won't cover this in detail in this session because this is mainly a beginner session. So we'll go ahead with manual color calibration, which I just showed. So we can go ahead and save this image at the moment. You can click on save and we'll save it here itself. This will be stretched combined Cyril. 16-bit, and this was a TIFF actually. We wanted to be fit. Stretch combined and TIFF. 16-bit TIFF file. Another thing, actually, you can manually increase the saturation over here, color saturation, but we don't want to do it over here. We can do it in GIMP instead. So by increasing this, you can see the colors got a bit more saturated, and this is a bit more extreme. So in GIMP, you can get more control over this. So I'll open GIMP, GNU image manipulation program. This was covered in the first session of planetary imaging, the second session which Arnav took, and now we are using it again. So this is a free replication of like Photoshop, and it's open source and available online. You can install it. Very useful for processing your own photos also, not just astro photos, any photos. So we'll open desktop and go NGC 5189. Stretched combined TIFF open. It's taking a bit while. Yeah. Yes. So you can see the image is still in a diamond shape. We want to crop it first. So we'll go ahead with rotate tool over here, click over here, and the cursor is set to the center of this. You can hold shift and keep the cursor, move the cursor. So when you rotate it, it rotates it about as an anchor. So we don't want to rotate like this. We want it to be in the center. So click over here, here, and rotate it. So I just check once Hubble's image was, how was Hubble's image? We'll use it as a reference again. It was like this. This band was in an S shape. Yes, exactly like this. So you can enter the degrees over here manually as well. It is exactly minus 45. So let's keep it like this and rotate. This takes a bit while to process. And after rotating, we can, computer has crashed weirdly. Let's hope that it doesn't get crashed. After this, we are going to crop the image and let's just wait for it. So GIMP is very poor at handling heavy images, sadly. Last session also we had to wait a lot for this. Hmm. Meanwhile, this is happening. We'll try to play around a bit more in Cyril. Let's see what we can do. You can stretch it a bit more using histogram transformation if you want. So you can see under histogram transformation, because this is an RGB image, you can now manually control the histograms of red, green, and blue over here. So if we want, we can manually increase the reds in this. We don't want it to be a bit more because the background will again change to orange. So have some control over this maybe. And click on auto, maybe to see how it operates. Yeah, so auto histogram totally ruins it. That's mainly because the image isn't cropped. So in this case, you would want that the image is cropped first and use auto histogram. So we just close this and use this. Yes, this should be done. Okay, not done. So we'll have to close GIMP. Really sorry for this. GIMP is a software which crashes often. We'll go ahead and open it again. I'll be a bit more quick this time. Not so quick that it crashes again, but open. Convert. Click. The anchor is set and -45. Rotate. Now it's a bit fast. We'll go ahead and crop the image. You can click on crop over here and select the area that you want to crop. So the edges over here have got certain defects over here. Maybe flat field correction hasn't happened exactly right over here. More about flat field correction and all will be explained in module 5, which will be today. So you can read about it and keep this like this and click on enter. Yes. Yes, so I'll just zoom out once. We don't want this. Yes. So we'll go ahead and increase the sharpness, improve the colors, and make this image pop out even more. So we'll go ahead to colors and firstly click on color balance. We want to make the orange areas of this image a bit more popped out. So we'll go ahead and maybe increase the yellows. Not so much. It looks green. So we keep it to 5. Increase the reds. Increase the magenta. Okay. So we can hover over the preview and click it. So this is before and this is after. I think the oranges have improved a bit more in this case. So we'll go ahead and click on OK. But we want the effects to be a bit more. We'll go ahead and repeat balance once again, but we can change the color temperature. So the image is a bit more cool. So we can change the temperature a bit warmer, and this looks better. So you can see the background is also getting shifted to orange, but for this you want to use masks. So what masks help you do is, like as its name suggests, it covers the background like a mask. You can cover the nebula like a mask and edit the background, or cover the background using a mask and edit the nebula. Here the entire image is getting affected. Masks take a bit while to make and process, and it's a bit difficult also. Not that difficult. You can explore it on your own, but I don't think we can cover this in this session. So it's a cool feature actually. So you can preserve the light colors of the background as they were, like grayish, black, neutral colors, and edit the nebula only. So, but in this case, we are editing the entire image. So this is the preview. I think this is good enough. The images, the colors are a bit more diverse, orange and blue. We'll go ahead colors, and we can increase the saturation. We don't want anything to be extreme. So this is a really unrealistic look. And at the start, it looked kind of undersaturated. So we can increase it to maybe 1.2 and click on OK. Then we can go and use curves. Yes, right over here. So curves, sometimes it's preferred to use it before a color adjustment. Sometimes people prefer to use it after. It's pretty subjective actually. In this case, we'll use curves after color adjustment. So we can make a simple S curve over here, tone down all the brightness values. Not so much that the background values actually become totally clip black. So we avoided histogram transformation because it made the central parts clipped white. That is, details weren't visible in the center. And we'll avoid using curves transformation in such extreme cases that the background looks clipped black. So both these cases are extreme, and the dynamic range is getting like totally screwed up. So we don't want these extreme cases. We'll just shift it a bit down, and to increase the brightness values, take this a bit up. You can see the preview itself. This is before, this is after. Maybe have it a bit not sharp and shift this a bit. Yeah. Okay. I guess this is good. Yes, we can go ahead and click on OK. And this is quite similar to the Hubble's look over here. So you can see this was Hubble's image. You can see actually even Hubble's processing, what they have done is not preserved the central parts over here. They might have used histogram transformation or some other transform that doesn't preserve the lightness. So here in this image, you can see the white parts are a bit clipped. So even Hubble's processing guys aren't like perfect. So you can go ahead and try to beat them, maybe register for an apod. You might win it. So you can see over here, the details over here are a bit more intact compared to Hubble. This part is white and this part has got these streaks much more clearly visible. So in that aspect, this is better. So how can we improve this even more? We can go ahead and click on color balance or hue saturation. So in hue saturation, you can change the hue of this. This is blue and yellow. We don't want this. We want it to be blue and orange. So change the lightness of it a bit more, a bit more bright maybe. Increase the saturation a tad bit more, 1.2. Yes, this is good enough. Yes. Now you can change the exposure, shadows, highlights manually also. So this is the shadows. You can increase the shadows over here. Background gets lifted up, not totally dark. So this can be kept at 25 maybe. Decrease the highlights. So the central details are a bit more visible. So this is the preview. This is before, this is after. There's much more to play around in this image, and we can go ahead and play around as much as we want. In fact, most of the images that I process take around like 1 or 2 days. So like I like to spend a lot of time in these images. It's similar to oil painting. If you know, like oil painting takes a while to make, sometimes months also. Not exactly, this doesn't take months to make, but I like to spend weeks maybe on one image. So it's an iterative process. So maybe something that isn't looking as appealing today can look appealing tomorrow. So tomorrow your mind can be a bit more refreshed and you can process an image much more better tomorrow. So I like to spend a bit more time processing an image. This was just a simple session, basic session. Took about 40 minutes maybe, and this was a rush through session. So if you really want to process good images, I would say like have some patience and process them really well. So we'll go ahead and save this image and export as GIMP final and save it as JPEG. If you go down, I get JPEG. JPEG. Export. It gets saved in the same directory. We want the quality to be 100% and export. We can in fact save this image also in the same directory for comparison. Where you save. Okay. This was in TED. Why isn't Hubble's image getting loaded? Yeah, here it is. So you can see both these images look really same. How can this image be improved a bit more? You can see this image has got way more blue in it. So there can be two reasons for it. One, because I processed it really fast and that can be my skill issue. So maybe I didn't process it as much and spend much time in this. So that can be one reason. I can increase the orange parts a bit more and stuff. But I believe the more important reason is that Hubble had used 5 different filters. So the colors in in this image are due to their usage of more filters. That can be one reason. So how can we use more filters? In Cyril, you can see when you do RGB compositing here, there is an option of using three different filters, that is R, G, and B. But we want to use more filters, right? I'll just go ahead and just a second. So you can see this filter 606 nanometers was used for dark blue. This was used for cyan. This was used for green. This for yellow and this for orange. So this is how they made this image. This isn't possible in Cyril as much, but what you can do is in GIMP, what was covered in last processing session, you can manually import the grayscale stretched images. So you'll save all these gray images from Cyril and import them in GIMP and have this color to be changed to like different colors. So cyan, orange, green, yellow. And then after combining, you will make one entire image and it will look very similar to what Hubble had processed. So I would definitely say this is very close to Hubble's image, but not exactly. If you want to get this result, the most important thing is spend a bit more time. This is a nice process, I would say, but not perfect. And there are many scopes of improvements in this. The stars are orange and the stars over here are neutral. They look white. The reason for this again is their use of diverse filters, which can be clearly seen because their stars are like white and neutral. For having this neutral look of stars, you can use photometric color calibration, which is a scientific method to color calibrate your images, and you can explore it on Cyril. There's a nice YouTube channel actually. Uh, Cyril processing tutorials. If you just search this, and yeah, this is the first channel that comes. Deep And this guy has got a really nice playlist on Cyril processing. You can go through it. And it was, I think, mentioned in the important links, useful processing sessions karke. And in that, this channel must be there. So Deep Space Astro, if you want to learn a bit more. And I guess this is it mainly. Another good channel is Nebula Photos if you want. Not Nebula, Nebula Photos. He has got really nice vlogs, not vlogs. Astro Backyard has got vlogs of astrophotography, but he explains basic concepts like using a simple DSLR and shooting targets. If you really want to get into astrophotography, the processing aspect, the shooting aspect, this channel was one of the first channels that I refer to. Really nice guy. I guess this is it then. And hopefully you guys enjoyed the session and thanks for being with us. And I guess end the meeting. The final assignment will be released by today, and the deadline for it will be like next week, and you can do it as and when you're free. So astrophotography is nothing to take stress off. It's just for you to chill out. And module 5 will be released also today before the assignment, obviously. The module 5 questions won't be compulsory. So they are free to attempt because even we know ki like we are releasing the module today and the assignment right after it. So it's not expected for you guys to attempt these questions from module 5. They are optional. And the final assignment will include a few MCQ questions, short answer questions, and mainly processing data sets. So there will be data sets from Hubble, uh, one of Planetary, a moon pic which our ex manager had taken, video of moon, which you'll have to process using these four software, pip, auto stacker, and registacks. We'll be giving like 5 6 options, and out of that you'll have to process only two. Okay, so like nothing is compulsory for you to do. So like if you don't want to process planetary images because like you have to install three different softwares, you can totally avoid it. It's up to you. And you can simply go ahead and process Hubble images as well, Hubble and JWST images. We'll be having JWST images as well. So James Webb Space Telescope, Carina Nebula will be there, and some images won't involve. So like the Carina Nebula dataset won't make it compulsory compulsory for you to use Cyril. That will be completely in GIMP. And some will include datasets that you have to process from the scratch. That is stretch in Cyril and process in GIMP. So it's a bit diverse. So some datasets will require only the use of Cyril. Some will require only the use of GIMP. It's totally up to you, and you can choose whatever you are comfortable with. So there'll be five, 7 options, and you can choose any two that you like to process. And the final assignment MCQ based है. So that's very easy to attempt, and that can be done very easily. So I don't think it should take more than like 2-3 hours to do the assignment. In fact, less than that. But ठीक है, there's deadline till like next week, and you guys can complete it. More than like having the correct questions, we want you guys to attempt the assignment out of curiosity, so that you explore these softwares and like process on your own. So I guess that's it. We can end the session. If anyone has any doubts, they can ask them. Yes. I guess Dipti had raised their hand. Do you have any doubt, Dipti?
Hello.
Yes, you are audible. Yes.
Okay. So like how many questions are there in the total? Like I have the assignments also. So
Mhm.
like is it possible like the questions are manageable, right? They are not
Yeah, yeah.
difficult.
Totally, totally. Like if you see in the other LS session that we are taking, theory LS, some questions are like JEE Advanced or Olympiad types. Vaisa type ka, it's nothing there in this. These questions are really simple MCQ based, mainly, or short answer types. Questions can be done within like 20-25 minutes at max. And the processing part, I was saying, it might take 2 hours for you. That depends again on the aspect, like how much time you want to put in. You can finish the processing part in like 20-30 minutes also, but that's something which I wouldn't suggest personally doing, because that's just rushing through the process, and matlab, it doesn't feel right, matlab, morally also, matlab, just rushing through it because you want to complete it. You can do it definitely. We won't like fail you or something. Yeah, totally fine with it. Yes, everything is manageable within like 1 hour also. Sure, then if anyone has any doubts, you guys can ask regarding the assignments or any process which you didn't understand. The recording will be made available, and these links also I will share once again, these useful channels and all. And the assignment will be released by today evening, and the deadline for it will be next week. If anyone has any doubts, I'm there in the meeting for the next 5 minutes, and you guys can leave if you want.